today in this video we'll be discussing the third module of embedded systems, and in this video we'll be first covering what are the application of embedded systems, and then we'll move on to the next topics. Okay, so if you like this video, hit the like button and don't forget to subscribe to my channel. Before starting, what is an embedded system? Embedded system is a hardware plus software designed for specific application like microwave or printer and printer and so on. Okay, so it's a microchip which will have the instructions written inside it. There are two types. First one is general, and second is embedded system. General is for the general purpose, and embedded system is for the specific purpose. Okay, so it's alterable, non-alterable, and it is not time critical, means the output is not so important here, and whereas the output at the proper time should is very important here. Okay, so these are the differences which you can form by yourself also. What is the general difference between a general, something being general and something being specific? Okay, so you can write from your own words also. And moving on to the next topic. What are the classifications? There are four types. First one is based on generation, second is based on complexity and performance, third one is based on deterministic behavior, and the last one is based on triggering. Let's discuss each one by one. Based on the generation, see here, in the first generation there were no big microprocessors manufactured. First one was 8-bit microprocessor. Okay, they were used in small objects like telephone keypad and stepper motor. Stepper motor is nothing but it converts the electronic data into mechanical data. Okay, like lifting an object from one place to another place. Okay, so these were used in the small objects, the first generation microprocessors. Then after that, the second generation were about 16-bit to 8-bit. They were used for storing the data inside the computer, like in the Excel sheet. Okay, so those were used for the Excel sheet purpose. And the third one is the 32 or 16-bit, which were used in areas like robotics, media, and industrial process control, and so on. Okay, and the fourth one is the mobile phones and the internet devices, in which the microprocessors are used, and it has high performance. And the fifth one is the next generation, which is highly dynamic and demanding, which can be used in IoT and robotics. Okay, inside the market. The second classification is based on the complexity and the performance. Like there are three types. First one is small scale, which are used in the simple applications like an electronic toy. And second one is medium scale, which is of 16 to 32 bit and used in microprocessor and microcontrollers. And third one is large scale, which are used in real-time operating system and PLDs and robotics. Based on the real time, there are two classifications. First one is hard real time, whose output is very necessary at the moment, and the soft real time, which are whose output is not that necessary, like voice recognition. Okay, and example for hard time real system is the satellite and live matches. Classification based on triggering means there are two types: time triggered and event triggered. Event triggered, you can consider an example of sensor, means if it crosses a particular point, sensor will give some output. That's based on event. That time triggered is like an alarm clock, and if the time at specific intervals of time, the alarm will sound. Okay, so these are the two classification under the topic based on triggering. So these are some of the applications of embedded systems: camera, and in home you can use for IoT or CCTV cameras, and industries USB and telephone, Wi-Fi. In hospital you can use for ECG, and bank and barcode. Barcode scanner means when you buy an object in the market, it will be scanned, right? So that is used. So for achieving that also, microprocessor are used. Based on the different applications, there are roughly 4 to 5 categories. The first one is data collection, storage, or representation. The best example is camera. In the camera, you'll have an embedded system to store the information of the pixels and the bits of the image. Okay. And the second one is data communication. Router will be having the microprocessor for transferring the data from one place to another place using wireless network. Okay. And the third one is digital signal processing, means it is the hearing aid is used to correct or amplify the signals, so the person can hear what the sound is. Okay, so for that also embedded systems are used. And the fourth one is which is used in hospitals. The heartbeat is being represented in the form of the digital signals by using a embedded system. The next one is the air conditioner and refrigerator to set the temperature of each of these. And the last one is the mobile phone. Embedded systems are used so that we can run various applications on the mobile phone. Second part of the module, will be discussing about the core of embedded system and the different types. Okay, so we'll be discussing these four types. And in the first type, we will have the general purpose and domain specific microprocessors, microcontroller, and digital signal processors. Okay, so let's discuss the first one, microprocessor. See, microprocessor is nothing but it's just a chip here which is dependent upon it's having many connections here, and it's dependent upon many other devices outside, okay, for input, output, and the bus operations. So that's known as microprocessor. There are two types. First one is general purpose, and second is application purpose. This you can write from your own words. Application purpose is defined for the specific purpose, and general is for the general purpose. And the chip cost is low, chip cost is high because it's specially designed, and so on, okay. And moving on to the microcontrollers, we have microcontroller will have everything inside it, okay. Means the IO operations bus and the storage memory and the CPU, everything will be inside the microcontroller, okay. So these are the independent devices. The main difference between microprocessor and microcontroller are given here. Like it's an internal central chip, and it's highly integrated, means all these things will be contained inside the microcontroller, whereas microprocessor is just a chip here which will have the external connections, and it's a dependent unit since it's having external connections, and this one is independent unit since it has all the things inside it, okay. And it contains inbuilt IO, and it does not contain inbuilt IO, and so on, okay. These are the general differences between these two. Moving on, the difference between the RISC and the CISC. RISC means reduced instruction set computing, and CISC means complex instruction set computing. It has a greater number of instructions, and this has lesser number of instructions. It uses pipelining, it does not use pipelining. Pipelining means performing of the same tasks, means parallelly, okay. In RISC there are large number of registers available because there are lesser number of instructions, okay. So more register will be empty, and here there are limited number of general purpose registers. And same things are here, like single fixed length instructions. Here the instructions are variable length, and for developing in RISC the programmers should not need not be much skilled, whereas for developing in CISC the programmers need to be very skilled because it's a complex set instructions, okay. So we saw overview of the microprocessor and microcontroller. Let's see the third one, which is digital signal processors. Among the three, the digital signal processor is the best one because it's 2 to 3 times faster, and it implements in hardware rather than firmware. And it has the structure as follows: PM means program memory, DM means data memory, C is the computational engine where all the tasks happen, like CPU, and IO is the interface between the external devices and the DSP. Okay, and it's widely used in the real-time applications. This difference is very important from exam point of view. The difference between hardware architecture and Von-neumann, okay. In this picture should be enough for you to know what is the main difference. See here, this is the program memory and CPU and data memory. These are connected with each other, but there is no single bus as in this case, okay. So here the data errors can happen because it's the same bus, and the data can be transferred here in the wrong address, and whereas that is not possible here, okay. Like it's high cost. Here it's high cost but easier to pipeline, and it's low cost here, but its performance is also low, okay. So there are a few more differences similar to it, so go through it. And moving on, we have the next one: big Indian and little Indian. See, it's very easy. In little Indian, the byte 0 and the byte 1 will be stored in the increasing order of the memory locations, whereas in the big Indian, what will be the thing? 0 from 0 to 4, byte 4 will be started, then byte 3, byte 2, byte 1, like in descending order, okay. So this is the main difference between big and little Indian. Next, we need to know about the load store operation. That means, consider an example here. This is the main memory here. In X, I have 00, in Y, I have 7F, and in Z, I have 23. So I want to add these two numbers and store in Z, okay. Initially, Z is empty. I'll be sending this to R1, I'll be sending this to R2, and these both will be sent to ALU. It will calculate the result and store in Z, okay. So this is the way the load store operation works. And what is pipelining? Pipelining means if I have to perform a few instructions, I can perform two instruction or more at the same time, okay. This will save a lot of time. So that's known as pipelining. Now discussing about the first part, general purpose and domain specific. Let's move on to the second one, which is application specific integrated circuits. It's a very small topic. Application specific, by the name only you can understand that it's designed for a specific or unique application, and it's very time means to design it, it's very hard, and it's costly also, and it's highly compressed and highly functional capabilities, and it's inbuilt, it can't be edited, okay. These two are done. Let's move on to the third one, which is programmable logic devices. Coming to programmable logic devices, that's mainly used in the cases where we have to convert some code to electronic signals, okay. In that case, we'll be using programmable logic devices. There are two types. First one is fixed one and the programmable one. Fixed one means once you have manufactured it, you can't make any modifications, and the second one is programmable. In this, you can make some changes according to your needs. Okay, it's rewritable. So in the market, there are main two categories: field programmable gate arrays and complex programmable logic devices. Both have their own advantages and disadvantages also. So in FPGAs, it's highest amount of logic density, and it offers much smaller than logic density than this one, but it is built-in hardware process, and they offer a very critical timing. Means if it's for important purpose, you can use this one. And the last one is it's used in wide variety of applications ranging from data processing, telecommunication, and digital signal processing. Okay, and this one is used in Xilinx and in mobile phones or any other inexpensive devices, and it uses extremely low power. Okay, we have discussed these three. Let's move on to the last one, which is commercial off the shelf. To understand this, consider an example of a product which is already created and it has some missing functionality. To implement this functionality, we will be using commercial off the shelf products. Okay, they provide designed in such a way to provide easy integration and interoperability with the existing system components. Okay, there may be general, domain specific, application specific, or programmable logic device. Okay, in all these categories, it's possible to build the commercial off the shelf products. Okay, and they are readily available in the market and they are cheap. Okay, important part of the processor and the controller, it's used in the embedded systems to store the data. There are two types. First one is on chip, which is inbuilt, and second one is off chip, which is externally connected. Okay, so there are few terminologies which we need to discuss. Which one is first one is program storage memory, rom is a memory which is permanent storage, which retains the data even after the system is turned off. Okay, so many types. First one is masked rom, which is inbuilt and can't be edited, and the second one is programmable read-only memory, one time editing is possible, and the third one is erasable programmable read-only memory. In this, using UV light rays, you can reprogram it, and if you do the same thing by using electricity, it's called electrically erasable programmable read-only memory. Okay, and the last one is flash. It's an upgraded version of the EEPROM and provides better flexibility and functionality. Coming to RAM, it's the RAM is nothing but it's a device used between the processor and the main memory to use the most recently data in a faster way, to avoid fetching the data always from the memory. Some data recently will be stored here, which we can access again and again in a less amount of time. Okay, so there are a few types here. First one is NVRAM. NVRAM means non-volatile RAM with a backup. Okay, it has a battery backup in case the power goes off for a small amount of time. It will have a battery in which the data can be retained. Okay, coming to volatile memory, where the contents get lost when the power is turned off, there are three types. First one is static RAM, second is dynamic, and third one is non-volatile RAM. Okay, let's discuss each of these. In static RAM, it's very costly because transistors are used and it's very fast also. Okay, so in very scientific computers, these RAMs are used, and in the normal purpose, the dynamic RAMs are used. It's cheaper and slower also, but it's widely used in day-to-day life. Okay. Based on a type of interface, the memory is divided into four categories: the parallel interface, serial interface, SPI, and single wire interconnection. About this thing, we'll be discussing in much more detail in the upcoming topics. Okay. So moving on to the next topic, we have the memory shadowing. It's nothing but when the system is turned on. See, this is the system. When it's turned on, BIOS is run, means basic input output operation is run. At that time, fetching from the main memory is very time consuming. So in the RAM only, the instructions to run the BIOS will be stored, and it will make the execution of the BIOS very much faster. Okay. So this is known as memory shadowing. Okay, and to select the memory for the embedded system, it depends on three factors: program memory, data memory, and memory for holding the non-volatile data. So for example, a simple device like an electronic toy just needs a few KB of RAM and ROM. That's enough for it. Whereas an RTO like satellite or the live events, for that it requires a lot of more memory in both RAM and ROM. Okay, a smartphone might need flash ROM because we need quick results to rewrite the program, whereas microwave oven does not need programmable memory, because in a microwave only one time if you set some instructions, that will be repeated over the lifetime of the microwave, whereas in smartphone the changes are to be made, so we need a rewritable ROM. Okay, so for representing a memory, we have not two notations. First one is in the form of bytes: 512, 1024, 2048, and each byte is divided into word size. Okay, so this is nothing but if this is an address of the memory, it's divided into many parts here. Each is called a word, and in each word you can have either 4 bytes, or total will be 8 bytes or 64 bytes, and so on. Okay, so word size is nothing but how many bytes are there in each row, and the size of the memory chip is the whole size. Okay, changes happening in the external world, the embedded systems are also changing according to it. So the sensors and actuators uh, help in the carrying out of the change. Okay, so what does a sensor do? Sensor changes one form of energy to another. That means if there if it senses a change in the temperature, it informs the embedded system, and the embedded system will take some action. Okay, and actuator is the device which converts the electrical energy to mechanical energy. Okay, so the code, or the electronic signal will be to shift shift this object from this position to this position, so that will be converted to mechanical task, okay, by actuator. And between the external world and the embedded system, there is in between IO subsystem which facilitates the um, activation and deactivation of the sensors and actuators. Okay, and by using LED we can display the numbers from 0 to 9 by using 7 LEDs here, and the LED has the anode and cathode, by using which we can um, give a visual representation of the data which we want to show. Okay, what does the optocoupler do? See here, this is the electronic signal, here also electronic signal. In between that, the data is transferred in the form of light. How? LED transfers the electronic signal into light, and the photodiode transfers the light energy to electric signal energy. Okay, so what happens is, in between that, the light is being sent inside this device, so the um, data is getting transferred in the form of light, and this device is known as optocoupler. This is a switch here, and by using electromagnetic induction, what we can do is we can change the magnitude of the induction here, and we can either open the switch or close the switch. Okay, that's the working. That's the application of relay. Piezo buzzer is nothing but a device here which will produce some sound here based on the voltage which you pass in. Okay, push button switch is a button which is used to make the circuit closed or open. Okay, so this is the diagram here. This is the switch, and if you push the button, it will be closed, or else it will be open by default. Communication interface means if this is the embedded system, and this is the external world, in between that, what is the medium of the communication? Okay, so there are two types. This one is external communication, and the internal communication means between the devices. Okay, so let's discuss each. So in the onboard communication, we have the first device, which is inter-integrated circuit. Okay, it is half duplex. Means half duplex means if this is the main highway here, either the car can go at this direction or this direction at a time. Okay, but they can go in both directions, but one at a time. So in the same way, it is half duplex, and it has two lines, one for the clock and second for the data. It uses master slave communication. Let's see by an example here. See how it is. Initially the master will be here and the slave will be here. Master gives the command to the slave to carry out some task. Okay, firstly, if the master wants to give some task, it will pull SCL to high, means the clock line will become high, and SDL will be pulled to low by the slave. After that, the master identifies which slave it want to address, means there will be multiple slaves. By using the address of each slave, it will say the address, and that slave will acknowledge it, and it will send the command here. And after that, it will carry out the command, and after the command gets over, the master will pull the SDL to high. When SDL is high, at that time the um, it terminates. Okay, means the communication between the master and the slave terminates, and the because the task is over. The second one is serial peripheral interface. It's the same as the previous one, but in this case we'll have three lines, which are due to which it becomes bidirectional and full duplex. Okay, uh, MOSI means master out slave in. Master out slave in means from master to slave. If the data is to be sent, it will be using this bus. And the second one is MISO, master in slave out. So slave will send some data which the master will take. Okay, so this is for the slave to master bus. Okay, and the middle one is the same as the previous one, which is SCL for the clock line. Okay, The previous cases we discussed was for synchronous, means due to some clock it will be synchronized, means at specific intervals of time it will happen. But in this case, universal asynchronous receiver transmitter, in this case the master and the slave will have the agreement, means handshaking property. If the master is ready to send and the slave is ready to receive, they will transfer the data. And same is in the opposite case also. If the slave is ready to acknowledge and the master is ready to take that acknowledgement, it will send that acknowledgement. Okay, so here the handshaking property is used, and a parity bit is included for checking the errors. Okay, the fourth one is one wire interface. This is the same as the asynchronous, means handshaking property between the master and the slave, but the only difference is that it is able to send the power. Okay, power will be sent between the master and the slave. Okay, means voltages. The sequence of operations are as follows. The master sends the request and the slave responds the presence, and by using network ID, which slave is to be addressed, that will be found out, and what to do, read or write, that will also be confirmed. But everything will happen in the terms of voltage and time. Let's see how it is. See here, initialization means the first setting up of the master and the slave communication will happen in this way. First, the master will pull low the clock line for 480 microseconds. Okay, and the slave will pull the clock line low for 60 microseconds. If these both conditions take place at that time, the communication line between the master and the slave will be initialized. After that, the operation should take place. Either it will be write or read. If it is write, master will pull for 15 microseconds. If it is a 1 bit, if 1 bit is to be written in the memory, at that time master will pull for 15 microseconds, else it will pull for 60 microseconds. If it's the operation of read, that means the slave should inform if it is a 1 or 0. At that time, slave doesn't pull the clock line if it is 1 bit, else if it will pull if it is a 0 bit. By using this, the timings and the voltage, the data is getting transferred. Okay, so this is the working of one wire interface. The next one is parallel interface. It's very easy, means there will be many lines here which will be performing read and write operations parallelly. Okay, so between the host and the device, and where to perform the um, writing and reading, that will be determined by the address decoder. Coming to external communication interfaces, the first one is RS232C and RS485. Okay, let's see what it is. It is full duplexed and is asynchronous, means it uses handshaking property. Okay, you might have seen the cables, right? Like some cables will be like this, somewhat like this. It will have some holes here, and this will be used to connect the modem and the laptop, right? So there are two types mainly. First one is DB9 and DB25. It will have 9 holes here, it will have 25 holes here. All these holes represent some protocol, like for transmitting, receiving, or request, or clear, etc. Okay, so these are used for the slots. Now let's give an example. Let's consider a small example for receiving and transmitting. For receiving, RxD is used, and for transmitting, TXD is used. This is the communication interface, and this is the terminal. In between both, the cross communication happens. That means the receiving end of this one is connected with the transmitting end of this one, and vice versa. Okay, by using this, the communication will take place, and two protocols, which are request to send and clear to send, are used to initialize the communication and to terminate the communication. Okay, and DCD and many such protocols are used to detect the signals and so on. Okay, and finally they coordinate with each other to output the desired result. And there are many versions like RS422 and RS485, which are better in terms of baud rate, means how much data is getting transferred per second, and there are multiple devices, can be connected to multiple devices at a time, and how much transmission distance will be possible, that will better in the different versions. Okay, coming to universal serial bus, it has the special property of connecting a USB with another USB. It's not like other devices which will be connected with the host to the device. Here we can extend the communication possibilities by connecting the USB with a USB. So there will be many more USB connections possible. Okay, so this transmit the data in the data packets, and address is set by the host. The top node is the host, and new device which are connected will be detected by the host at specific intervals of time. Okay, so the types of transfer include, you can either transfer the configuration information, means if any new device is connected, the address of that, and the block of data, or real-time data, or small amount of data. Okay, these data transfers are possible. IEEE 1394 is a cable here which supports isochronous transfer of data, means real-time transfer of data, and it's very high speed transfer of data, and it supports 63 devices, and it doesn't use any host. Okay, because the data is being transferred between two devices. Okay, and you can directly connect a scanner with a printer, means many possibilities are there for faster transfer of data, and it is used in a device like camera, camcorder, scanners, desktop computers, and so on. Okay, the fourth one is the wireless one, which is infrared. You might have seen the TV remotes that when you click here from your seat, the TV's channel will change or the volume will go up and down. Okay, so that is possible by using infrared, which is the spectrum in the electromagnetic spectrum, which is not visible to the human eye, but it comes under wavelengths of 700 nanometers. So that will be used for transferring the data, and it is half duplex, means at a time only you can transfer from one end, and it is wireless, and it has two components, the transmitter and the receiver, and it has two communication paths. First one is the physical link, means inside the remote, and the protocol part, means the transfer of the data in the wireless form. Okay, so the physical layer is responsible for the physical transmission of the data between the device supporting the communication, and the protocol is responsible for determining the rules of communication. Okay, means from what distance you can use this, and in what direction you have to point, and so on. Those rules are determined by the protocol. Okay. The fifth one is Bluetooth. In Bluetooth, you'll have a 48-bit ID, and it uses a master-slave relationship, and it can be transferred using 1 MB per second, and at a distance of 30 feet at max. Okay, in this um, in this range, the data can be transferred, and to access a Bluetooth device, the generic access profile is used. Okay. Wi-Fi can be told as a better form of Bluetooth because it supports a large range of devices, and the data transfer rate is also very high, like from 1 MB per second to 1.73 GB per second, and more than that. And it has a range of 100 to 300 feet, and it uses Internet Protocol, okay, to identify which device is connected to the Wi-Fi. Okay, ZigBee is similar to Wi-Fi, but it is used in smaller areas, okay, like in office and school or other places which are confined to a company. Okay, it's used in the local and personal area network. So it consists of three components. First one is ZigBee coordinator, which manages the network, the main part here, and the ZR, which is the ZigBee router, which is responsible for connecting other devices and transferring the information. And ZigBee end device is the end device, which means the main devices which are connected here. Okay, so this is the main route. It will have the routers here, which will connect the devices. Okay, so this is the rough diagram of the ZigBee connection. And the last one is the general packet radio service, which is the radio waves. So by using the radio waves, also we can transfer the data over the mobile communication network, and the transferring happens in the packets at a speed of 171.2 kilobyte per second, and it's mainly used by mobiles enabled embedded devices for data communication. Means those mobiles which have the embedded device included in it can support the radio in it. Okay. What is embedded firmware? See, firmware is nothing but it has the set of instructions written here, and it's a microchip which will be performing the specialized instructions written in it. Okay, so there are various methods for developing it. First one, you can write in high level language and use a integrated development environment, or you can write in assembly level language using the translator. You can convert that into hex file and then binary file. Okay, so the algorithm is divided into mainly two parts. First one is while loop type, means all the tasks will be written like procedure oriented programming, and second one is the object oriented programming, means the whole task will be divided into multiple tasks which are being executed parallelly and independently. Okay, so the failure of one of those will not affect the whole program, whereas the failure of one line of code here will affect the whole program. Okay, reset circuit is used to reset a device in case if the device got stuck, or it falls in the case of deadlock. So at that time, reset circuit is used. There are two types. First one is the active high and active low. Both do the same thing, but it's the change in the configuration. Means in active high, the capacitor will be on the upward direction, and in the active low, the capacitor will be down of register. Okay, so what happens is when we use this active high and active low reset circuits, it sets the vector to all the registers to 0. Okay, 0 vector state, and starts the execution from there. Means from the starting point the execution begins. Okay, so this is the working of reset circuit. And the next one is, and by using the brownout protection, we can prevent the process from unexpected program execution behavior. Okay, When the voltage falls below a specific voltage, it will stop the execution and it will save the process from performing unexpected behaviors. Okay, so brownout circuit is used by the BGTs and registers. Okay, by using the BGT and register, we can implement the brownout circuit protection in this reset circuit. Okay, as we had discussed before that there are some clocks in the computer which generate the clock pulses at specific intervals of time. Those are made up of the oscillator units. There are two types. First one is quartz and the second one is the normal oscillator unit. Okay, so this gives a more precise value of the time, and both use the microcontroller and microprocessors for the digital combinational and sequential circuits. Means digital combination means the output will depend on the previous outputs also. See here, if it is register here and second register here, and if the second output will depend on the output of the previous value also, this is called as combinational circuit. And sequential circuit means only it depends on the internal values, means only it depends upon the present input values. Means if it is 1 plus 1, then it will be 2 here. Okay, and 2 is not connected to the previous output here. If it was connected, then the next output will be 1 plus 1 plus 2. Okay, this combinational circuit. And the sequential means it just depends on the input values. So in both of these cases, we'll be using the oscillator circuit or oscillator unit to generate the pulses, means when the input should change to the registers. Okay, real-time clock is a component which handles the which is responsible for keeping the track of time, like in 12-hour format or 24-hour format, and date, month, and year. Okay, it should also perform when it is when it is in the absence of power. Otherwise, every time you reset your device, at that time it will show the reset date. Okay, so that should not happen. So the device used are not discussed here how it happens, but this is the thing, and it can be used for the alarm also using the OS kernel. And it's connected to the OS kernel, means the main root of the every device. OS kernel is connected and handles the information transmission. Okay, from the OS to the screen it will be transmitted. Okay, watchdog timer is nothing but it monitors the firmware execution and resets it when the system processor or microcontroller when the program execution hangs up. When the program stops executing, at that time it will reset it. It will monitor the firmware for errors or bugs. Okay, lastly, let's discuss about the device on which all these devices which we just discussed about are kept. Okay, that's known as printed circuit board. It is an architecture, means what device should be placed here and how it should be connected and so on. Okay, this is the main base for the microchips and the micro controllers. Also, it acts as a platform for testing the embedded firmware. Okay, so these are the necessary components which we need to know in this module regarding the embedded system. Okay.